You're welcome to this video, and in this video we are going to learn the basics of complex numbers. The basics of complex numbers. Now, complex number is used to resolve the square root of a negative number. The square root of a negative number by representing it with a particular variable. Now, if we say let I as a complex number be equals the square root of minus 1. It then follows. It then follows that I squared equals minus 1 all squared, which equals minus 1. Also, I cubed equals I squared dot I, which is equals minus 1 dot I, which is equals minus I. It also follows that I raised to 4 equals I squared all squared, which is equals I squared is minus 1. So minus 1 all squared, which is equals 1. If we continue as if I raised to 5, we'll have I raised to 4 dot I. Now I raised to 4 is 1, so we have 1 here multiplied by I, which is I, positive I. So the square root of a negative number is a complex number. The square root, a complex number is simply the square root of a negative number. Now, how do we resolve the square root of a negative number? Or how do we resolve a complex number? It's by representing the complex number with I, where I represents a complex number. For instance, in this case, if I equals the square root of minus 1, then it follows that I squared equals minus 1, I cubed equals minus I raised to 4 equals 1, and I raised to 5 equals I. How then can we resolve even more complex problems involving complex numbers or involving higher powers of I? It is simple to resolve. For instance, if we take I raised to power 9, more complex examples, more complex examples. If we take I raised to power 9, I raised to power 9 is the same thing as I raised to power 4 all squared. Now 4 times 2 is 8. For us to complete the 9, we have to multiply by another I. Now I raised to power 4, very important, is 1. From here, I raised to power 4 is 1. Then 1 times I is I. Okay, it's 1. 1 squared multiplied by I. 1 squared is 1. Then we have 1 multiplied by I, which is I. So what if we take a higher value of I, higher powers of I, say I raised to power 15. So if you ask, we can resolve, we always look for the, if the I, this can be resolved with I raised to power 4 multiplied by, say, 3. 4 times 3 is 12. For us to have 15, we need 2 more to be added. So we can have I squared here. So this is I raised to power 4 raised to power 3 times I squared. By the time you multiply this 12 plus this using simple addition of powers in the laws by obeying the laws of indices, we'll have 15 there. So it conforms to this original. So they are the same. They are the same, but different representations. So I raised power 4, we already know that I raised power 4 is 1. Then we have cubed multiplied by I squared is minus 1. So this becomes I cubed is 1 multiplied by minus 1, which is minus 1. So this is what we have. What if we go further to take higher values of I raised power 20, for instance? I raised power 20 is the same thing as I raised power 4 or raised power 5. 4 times 5 is 20, so it's equal to this. So I raised power 4 from our initial expression is 1. I raised power 5 is 1. What if we continue I raised power 30? I raised power 30, we can say I raised power 4 all multiplied by, if we multiply by 7, we'll have 4 times 7 is 28. So once we get 30, we have to multiply it by, we have to take another power of 2. So 28 plus 2 is 30. So what I raised power 4 is 1. Raised power 7, then I squared is minus 1, which is equal to 1 bracket minus 1, which is minus 1. So this is how to resolve higher powers of a complex number. Higher powers of a complex number. Now, with these basics, it is easy for us to carry out addition and subtraction of complex numbers, and also carry out multiplication as well as division of complex numbers, or resolving any problem involving their interactions like that. So I believe with this, we have learned something about how to resolve the basics of resolving higher powers of complex numbers. Thank you.